Okay, let's get started on this topic of interpenetration of solids. We have the surface of revolution here, and we have a prism, triangular prism that is, and we have to find this intersection line here, or contour. There is a certain ways you can do it, but I'm going to use one which is really useful and unique when it comes to surfaces of revolution. It works really well with cones, cylinders, this type of surfaces, and also torus, and maybe it can work with half globes as well. It mostly works. So let's get started. We need to introduce cutting planes, only horizontal cutting planes. That's what we are concerned about, such as we get circles in intersections. I'll show you what I mean in a second. So that's what the objects look like in 3D, and we need to find that intersection, as I said. But first, we need to draw it on diagram. This is one of the examination cards. Yeah, I'm showing it to you, but I'm not going to be using this set of questions. I'm just using this as an example, and I want to show you how we can construct this, because it is something we have not really worked on. So what do we have here? We have surface of revolution, and there is no axis given on anything. That means we are free where we start drawing this object. So first we can like most of you wonder how this is drawn. Well, it's quite simple. There are some dimensions missing. It should be 80 here, or yeah, it should be 80 here, and it should be 80 here as well. This symbol means the diameter, and this symbol means the radius. So anywhere we like, maybe here, we put the compass and measure out 80 on x-axis. Then you draw an arc. Doesn't matter. Just draw it at least a quarter of an arc. Then from here you measure out a compass, again 80, or at the previous point where you had the compass adjusted to. So where you intersect with this one, you just erase these parts, and that's it. You have this shape, a dome, drawn. Next, let's draw its horizontal projection, which would be, let me just borrow this line. It's somewhere here, it's center, obviously. And again, we are not really given what's the relation between them, how far does it go, or how far it, or how close it comes to the axis. So we are completely free in that regard. I'm going to eyeball it and do it like that. So maybe somewhere here, I need a radius of this much, which is 40, or diameter of 80. This should be diameter, or the other way you can find it. Maybe you take this one down and you have this one maybe here. Just say we have a center there. That's our center point, let's say. Then what we would do is take the compass, put it in the center, measure out to this intersection, and scribe an entire circle. Alright, we can erase this part. This one isn't necessary either. And let's just erase extra guidelines. We don't really need them for now. And now, how do we draw this triangle, which is the base of the prism? Well, it's quite simple. We know that this line, this level line, goes up by 15. So let's try to replicate that. We go up by 15 and draw a line. Doesn't matter. I'm going to draw a long line like this. Next, I also know that, well, let's mark the center point and see what I mean. And we have a center point, and we know that this apex, or this corner or point of this triangle, or the base of the prism, is also located on this axis, right? So it's up, it goes up by 40. Its elevation is increased by 40. So from here, you measure up 40, like that, and let's just get a point there. Let's just mark this point. It's going to be necessary. Next one, we know that this one comes out by 24. So let's move out here by 24. Mark this point right here, and we can join it to the previous point. But how about this one, the other point here? It comes out by how much? We need to define that. So entirely we know that this triangle is 80, so this base should be 80. So what we can do is measure from here to here 80, and that's how it would work. So let's just do that and join it up here, and we can erase the extra parts like so. We don't really need this, or I'm going to leave it in dashed lines like this, just so we know it's the center of the rotation. Okay, next let's complete the top view. Again, we are told it's 90. It doesn't matter, it's exactly symmetrical, but it doesn't have to be. It doesn't really change the intersection. So let's not really worry about it, but I'm going to try and keep that as it should be. So let's also draw this line, and let's stop there because we don't really need another um, center line. We don't need a vertical center line because it is aligned with this line, which is well, this. Let me show you. So the center is aligned with this edge right here. So let's just replicate that on the drawing. We know for sure that all of those are like this, somewhere here, somewhere like this. We don't know where exactly, but we know its entire length is 90. So let's just replicate that. From here, let's measure 90. No, not 90, 45. It should be half. My bad. Like this. Let's just draw the entire thing, and we can erase the extra parts already, like so. You can do the same. If we measure 90 somewhere here, we can also draw the line. I'm simply going to replicate this. Okay, that's it. Now that we have this drawn, I want to get started on the intersection, how we do that. I'm going to show it to you in 3D, how it's done. So let's say we have this object. Let's move on to isometric, like so, okay? How do we define this contour here? Well, we can use the horizontal uh, section planes, and let's see how they look. If I take this cutting plane, move it down, and you see it starts to cut this pink object, and as it cuts, it's only giving me circles, nothing else. And when this thing comes in contact with the prism, now you're seeing I'm getting two lines, two generators. It cuts this prism in points on the base, which then gives me generators, okay? Like so. If I find enough points, now pay attention of the generators and the intersection of the circle. That's exactly what I need to find until there is no intersection, and then the last intersection, which will be the base of the or the most lower face of the prism. So first, let's just take this point right here and find it where it is and how that looks in 3D. And right here, that's our first intersection. That's our first point. So in front view, obviously there is not much to define. It's already defined mostly. There are still some lines we need to draw or erase, but we'll get to that. The main thing is the top view. We are only or mainly concerned about the top view. So what we did here, uh, that we sliced it with this cutting plane, how that looks in front view or anywhere. In top view, obviously it doesn't look like anything because it would cover up the entire drawing, so we don't want that. Only thing we are going to do is draw this line here, which would represent a cutting plane. It's sliced. We can give it a Greek alphabet, but I'm not going to waste any time labeling the points. If you do that, much better, more power to you. But if you don't have time for that, it's okay. I'm only concerned about the points here. So the first point I'm getting is this one. Obviously, it's located on this edge, but I don't know where it is or where it enters. Like I need to find this point and this point, entry point and exit point. So let's do that. And as you saw in 3D, it sliced some kind of radius or diameter on this surface of revolution. So let's just replicate it here. Well, how we do that? Simply just taking a point, dropping it down to this axis, and then drawing the circle, like so. So I know that this edge enters here. So let's just mark that. Like this. We have two sets of points. The more we do it, the closer we get to the answer, but I'm not asking too much from you. Maybe do two more planes and you're good to go. Let's do one more here. Let's move this plane down by 10. I'm just doing it. You can draw it randomly. We just need the directional points. More we take here, as I said, more accurate it will be. So let's just continue moving it down by 10. Like so. It's going down, down, down. Somewhere here. Okay. It's actually not in scale, so maybe I didn't really write 10. And now we have two surfaces. Well, this one looks like wood and this one looks like metal. And this one gave me generators. I am concerned about these generators. I need to mark those, and also this diameter, or this circle with this diameter. Let's just replicate that here. So these are the points which was cut, or the generators which were cut here, like so. And we just need to find the circle, another circle. I'm going to erase this one just so we don't get confused with this. But obviously we'll have to leave it on the paper. So let's just drop this one down. That would give me the measurement for my compass. So if I draw this entire circle, then I need its intersection. And I'm getting two rabbits with one stone now, or two birds with one stone, however that saying goes. I also get these points of intersection and these pairs of intersection. So let's just mark them. Here, here, here is one, and here is one, like this. Let's do one more. Maybe here. And in 3D it would look like moving our cutting plane slightly more towards the ground, like this. And we do the same procedure, nothing really changes. I'm just going to erase this part so we don't get confused. We also need the generators here, and this one comes here. And for the circle, we measure it to this one, and where the intersectors, here, 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 and here. So let's just do that. Mark those points. And as you can see, it's exactly the symmetrical object. And now, quite important part. This one has an extreme point, this intersection. One of them is the lowermost point right here, so we need to find it. We do that by constructing a plane going through here, like this. And how that looks in 3D, I'm going to show you right now. Like so. That's where the intersection happened. It's exactly the tangent. And we are also getting some extra points over here, so might as well use it. We know it's going to be here. We don't have to draw it anymore because it's on the extreme generator of this, let's call it the dome. But let's meanwhile find this one, this generator right here. But also we are going to still need um, the radius, obviously. So let's drop it down right here. I'm going to erase this one and move on to here. Also, we don't need this one, just so we don't get confused. Here, so we are just looking for this point and this point here. See, more points I have, the smoother it gets. And now for the last points, it's just this base, and it's going to give me a nice juicy circle there. So let's just move it down, just so you see what it looks like in 3D, and that's it. There is nothing left of this. You can see it's just yellow thing. So that's the base. So we need to find these 2 points, and that's it. Let's erase these ones. Find the last one here. And last pair of points. I don't have to draw this one because it's going to give me the same line as I already have here. It's just going to show me the endpoints here and here. So now we need to oh, hold on, I forgot to mark this point, which we already did right here. Okay, I erased this line without even drawing it back. So here, what we need to do is to join the entire drawing now. So I'm going to simply take this, borrow it from there, and draw the entire contour like this. I'm going to stop here. I'm not going to go all the way around. And then I'm going to continue from here to here, like this. But here I'm going to come all the way through, like so. That's the intersection point, but we are not done yet. There are some visibility questions we need to see first. So now let's look at this thing. When I'm looking at it like this, I don't see part of this dome. Therefore, that part on diagram will be hidden. So this part will be hidden. Let me just erase this. So what you can do is take it and draw as a dashed line like this. And the last part, this lower base, even though we found it, there is an intersection going on there. Let me show you in 3D. There is also the intersection, this one we need to show, but it's not visible while looking at it from the top. As you can see, this one is obscuring it, which we all have already found. But this one, we still need to show it with dashed lines. It's going to be same as this circle. So I'm simply going to erase that part and take this one and make it dashed, and that's the end. I'm going to give it a red color as well, just in case. So yeah, that's the idea of this, but we are still not done. When intersection happens, when this one enters, until it comes out, it's hidden. We already talked about this, so I'm going to just show you how it would be. Like this, and same goes for this edge here. It enters and then it exits. So this looks like this. So that's the end results. Let's move to 3D just to show you what I meant. So as this edge enters here, it gets hidden, and until it comes out, it stays hidden. Then when it comes out from the object, it's again visible. Same goes for this edge, obviously, but this edge is outside, so yeah, there is no point in defining the visibility there. So again, that was the idea of this all, and even though this one looks like this, there are other variations of it. Some of them are easier and some of them are, I will not say difficult, but different slightly. But the idea and principle is exactly the same. You use horizontal projecting planes and find the diameter, and or I should say combination of the diameters or the circles with generators. That's it. So let's wrap it up here, and maybe I'll find another topic I need to discuss for the exams. So yeah, good luck.